Hello, and welcome to the podcast. Today, we're diving into a revolution happening in the world of science, specifically how we find new materials. Think about it. Better batteries, faster computer chips, new medicines. They often depend on discovering materials with just the right properties. But traditionally, this has been a slow, painstaking process. Researchers rely on intuition and endless trial and error experiments. It can take years, even decades, to get a new material ready for use. But what if we could speed that up dramatically? That's where a new concept comes in: the AI-driven autonomous laboratory, sometimes called a self-driving lab. Imagine a lab that runs itself, combining artificial intelligence with robotics and automation to discover materials faster than ever before. How does it work? These labs operate on a continuous closed loop, often called the Design, Make, Test, Analyze cycle, or DMTA. Let's break it down. First, design. AI algorithms sift through massive amounts of scientific data and predict new material combinations that might have the properties we're looking for. AI can explore possibilities humans could never dream of. Some AI even designs the best synthesis recipes. Next is make. Based on the AI's predictions, robots automatically synthesize tiny samples of these candidate materials. They handle chemicals, run reactions like mixing or heating, and work around the clock, dramatically increasing how many experiments can be done. Then comes test. These freshly made materials are automatically sent to instruments that measure their actual properties, like their structure using X-rays or their optical properties using spectroscopy. These measurements tell us if the material works as expected. Finally, analyze. All this test data feeds back into the AI system. Machine learning analyzes the results, comparing them to the predictions. The AI learns from both successes and failures, updates its understanding, and then intelligently decides what experiments to try next. This closes the loop, starting a new cycle of refinement. This isn't just science fiction. Labs like the A-Lab at Berkeley, Polybot at Argonne National Lab, and platforms developed by Natural Resources Canada and the University of Toronto's Matter Lab are already using this approach. They've successfully discovered new best-in-class materials for lasers, electronic polymers, catalysts for clean energy applications, and materials for efficient energy conversion. The AI driving these labs is getting incredibly sophisticated. Beyond specialized models, large AI systems similar to ChatGPT are showing potential in scientific reasoning. Physics-informed neural networks embed physical laws directly into the AI for better predictions. Active learning techniques also help the AI strategically choose the most informative experiments, reducing wasted effort and finding optimal materials faster. Looking ahead, these autonomous labs are expected to tackle even more complex problems, maybe even designing entirely new biological systems or discovering novel enzymes. Integrating more advanced context-aware AI will make them even more powerful tools for scientists. We're also seeing the development of supporting software frameworks and cloud platforms, which could make these powerful tools more accessible. While there are challenges in scaling up, ensuring standardization, and managing the huge amounts of data generated, AI-driven autonomous labs represent a fundamental shift. By automating and accelerating the slow process of discovery through these engineered closed-loop systems, they promise to deliver the crucial new materials we need to tackle major global challenges in energy, health, and sustainability much faster than ever before. It's a truly exciting time for materials science.